Alright, so now let's continue with our ArrayHeap class. So we will create a new class. I'm going to right click my src folder and click new Java class, and then we'll put here we'll put ArrayHeap. We'll call it arrayheap.java. We're going to use generics again, so we'll say public class ArrayHeap of type T will extends array binary tree of type T and implement heap ADT of type T. So here we'll say array, whoops, need some slash star star. So we'll say ArrayHeap provides an array implementation of a min heap. So in a min heap, the minimum elements in the root. In a max heap, the minimum elements in the root. So we're doing a min heap, so the minimum element is going to be in the root, and the left and right child will separately be greater than or equal to its parent node. So the left and right child will be greater than or equal to its parent. So it's different than the binary search tree where it has a left is left and right is greater than or equal to. This time left is greater than or equal to, and so is the right child. So it can be a bit confusing, but if you get that down, it should be alright. So yeah, I spelled that wrong, so that should be okay. Here we'll say creates an empty heap. We'll say public ArrayHeap. We'll call our ArrayHeap constructor, and we'll just call the super reference to set up all the instance data in the fields. Here we'll do the add method, so we'll say adds the specified element to this heap in the appropriate position according to its key value. At param we'll say TOBJ, or at param obj, excuse me, the element to be added to the heap. Here we'll say public void add element, and we'll say it takes a TOBJ as parameter. Here we'll say if count is equal to tree.length. We'll expand the capacity. What's wrong with that? I think there should be a period there. So we'll expand the capacity if count is equal to tree.length. So if the array is full, then we're going to expand the capacity. If not, we'll set tree of index count to point to the obj, the object, and then we'll say count plus plus and mod count plus plus. And we'll say if count is greater than 1, then we'll call heapify add, which we haven't created yet. And that's it. So count is up, where is count? Count is in our other tree, array binary tree, so we have access to all that instance data here. We have a count here. Every time we add something, we're going to check if it's full. If not, tree of the index, so count is going to be like top. The next amount of elements in the array and the next element available. So let's say there's 0 elements, and we're adding our first element. Then count is going to be set to 0. Then when we add our first element, we're going to say, okay, well, tree of index 0, which is a root, points to the object count plus plus mod count plus plus. That's it. The next one, if we're adding another element, the count's going to be incremented by 1. So if it's full, check that. If not, tree of index. I like to put a bracket here just because it seems better. So we'll say then I can move these up, and I can also put a bracket here as well, and then I can keep them all together like that. So if count is equal to tree.length, expand the capacity. Otherwise, tree of index count, which is 1 now, tree of index 0, 1, so the second index, which is 1, points to the object count plus plus mod count plus plus. So that's all it does. Nothing too hard, except we haven't done the heapify add yet. There's going to be a little formula for it. So we'll say down here, reorders this heap to maintain the ordering property after adding a node. There's going to be a little math calculation in our index to check it. So we'll say here private void heapify add. We'll say ttemp int next points to count minus 1. Then we'll say temp points to tree of index next, while next does not equal to 0, and comparable cast it to temp dot compare to tree of index next minus 1. Next minus 1 divided by 2 is less than 0. Should just have 2 brackets on there. And 1 bracket there. Then we'll say tree of array index next points to tree of array index next minus 1 divided by 2. So there's something wrong here with the parentheses. So while next, also there is 2 brackets here. Whoops, parentheses I mean. So 2 brackets and 1, and then 3 parentheses comparable 1 temp dot compare to tree of array index, and then next minus 1. Okay, here there should be a parentheses here divided by 2. No parentheses there. Parentheses here. Less than 0. Okay, so it's a little complicated to format those brackets. But after that, then we'll do tree of next points to tree of next minus 1. So personally, sometimes I forget how Java divides. So I think if it's a number less, if it's a number greater than the top, so if the number on the bottom is greater than the top value, then it's usually just 0, I think. But I forgot, because sometimes it's a little confusing. But we'll figure it out. So tree of next points to temp. After all that, actually no, sorry, we have one more line here. next points to, again, you can always check with like another compiler or like an online Java compiler or something if you're confused. So next points to next minus 1, and then divided by 2. Whoops. Next points to next minus 1, and then divided by 2. Then we'll say next points to next minus 1 divided by, did we already say that? Yeah, we already said that, so that's good. After that calculation, we'll have tree of index, array index next. Points to temp. Then we just have remove min and heapify remove, and that's it. Do we have, oh, there's one more. We have to implement the get the find min, which is returning array index of 0. We should probably throw the collection, throw the exception if it's empty as well. So after that here, we will do the remove min. So here we'll have remove the element with the lowest value in this heap and returns a reference to it. Throws an empty collection exception if the heap is empty. Whoops, didn't want to go out of those, out of the doc. So then here we'll say return a reference to the element with the lowest value in this heap, and throws empty collection exception if the heap is empty. We'll do public t remove min. Throws empty collection exception. That's it. So it's going to throw the collection if it's empty. So the exception if it's empty. So if is empty. What are we going to do? We're going to throw the new empty collection exception. And here we'll say array heap. Then down here we'll say t min element points to tree of array index 0. So t min element points to tree of index array index 0. And we'll say tree of index 0 points to tree of count minus 1. So it's saying, okay, we have a t minimum element. That's our tree of array index 0. Then we're going to say, okay, well, tree of array index 0 points to tree of count minus 1. Then we're going to heapify remove. Which we don't have, we'll count minus minus. So we're going to swap the root with the bottom right element. I believe that's what it does. The very max element, and then it's going to, I think that's what it does. I can double check that actually. But I'm pretty sure when we remove something, when we remove the root, we swap it with the we swap it with the last node. I think that's correct, and then we heapify it. We shift everything. So I think I have the node here somewhere on the heap itself. So removing the min element. Yeah, so we take the last node and replace it, and then, so, okay, so let's say we want to remove, how can I do this as an example? I'll just tell you, so I don't want to spend too much time explaining it, or else I'll spend another half an hour just drawing this diagram. So I'll just say we have a bunch of elements, and let's pretend the root is 5, the left is 6, the right is 11, and so let's say we have like 5 or 6 elements. Let's say the root is 5, and the 6th element, which is going to be on the 3rd level. Let's just say the last node. You know what the last node is, so we know what the root is. We're going to set the root to null, basically, and then we're going to replace it with the last node, right? And then we're going to reorder the heap. So that's all we're doing. So we'll try to do a walkthrough here in the debugger. I think I was trying to find my spot where it was in the code because I had moved up. Okay, so we have remove min, heapify remove, and then count minus minus, and then we'll have mod count minus minus as well. We're going to decrement those, and then we'll have return min element to be removed. So we didn't really set anything to null. We could have said maybe, okay, we could have first set tree of index 0 points to null. Then, does that work? Yeah, it does. And then we could have said tree of array index 0 points to tree of array index count minus 1, but we don't really need to do that because we're just going to delete that element, get it eligible for garbage collection, and then we're just going to take index 0 and point it to the count minus 1 directly. So we don't need to delete anything there. It's not like it's a link where we have to delete it. We can just swap the index. We can change the index, and that's all we have to do. So it's much less code than besides the calculation, which is going to be kind of confusing. I remember walking through this trying to do the division. But other than that, it's less lines of code. It's actually the next method is kind of long. It's the same. The heapify codes itself are long. So that's okay. We'll do the last method. Actually, the second last one. The other one's a small one. We're just returning the root. But here we'll say reorders this heap to maintain the ordering property after the minimum element has been removed. So we'll say private void heapify remove. So we have a t temp, an int node set to 0, an int left set to 1. Okay, I think I remember this. Int right points to 2, int next, and we'll say if tree tree of index left. So there's a number stored in the left for left which equals to 1 is equal to null. And tree of array index right is equal to null. Then we'll say next to point to count, or set next to point to count, I mean, and then we'll say else if tree of array indexed right points to null, and we'll set next to point to left, else if comparable of tree of left compare to tree of array index. Sorry, so comparable casted to, let's say casted to. Yeah, I should make this a little bit bigger. I can't see my code and it's too far down the screen, so I'm going to move it up. You can't see that, I think. So we'll say else if comparable casted to tree of array index left dot compare to tree of array index right is less than 0. Then we'll take next and point it to left, and that's going to say that it's an unchecked. Okay, that's fine. And we'll say else next points to right. So if you don't like that orange lines, those orange lines, you can suppress warnings up here if you want to. So else next points to right. That should be fine. Then we'll set temp to tree of array index node. Done. Is that done? Really? We're all done? Oh no, there's another whole bunch. So we got something else here. Another basically double of that. So we have while next is less than count. And another comparable cast. Comparable of tree to next. It would have been easier probably just to cast these at the top. Next dot compare to temp less than 0. Tree of node. Tree of array index node points to tree of array index next. Node points to next. The left points to 2 times node plus 1. Right points to 2 times node plus 1. Yeah, I think we're only going to add 1 or 2 elements. Actually, I think we're only going to add, we're going to add a few and then we'll just remove 1 because it's going to take forever. Right points to 2 times node plus 1. Then if tree of array index left points to null and tree of array index right points to null. Next points to count. Then we'll say else if tree of array index right points to null. Next points to left. Else if comparable casted to tree of array index left dot compare to tree of array index right is less than 0. Looks like I have too many brackets here. We'll set next to point to left. Looks like there's a bracket that's messed up there somewhere. Then we'll say next points to right. So else if 3 parentheses comparable tree of array index left. Oh, there's supposed to be a bracket there. Dot compare to tree of array index right. Okay, so there's a bunch of stuff in there. It's going to be hard to think of just in your head. So we'll use a debugger, and then we'll say here tree of array index node points to temp. And we just have about 10 more of these statements to do and we're done. No, I'm just joking. Be here like another 4 hours. Not including testing, or maybe including testing. So that should be all of it. we have that one more method. That was remove min. No, find min. Where are we here? Array heap. Yeah, so we'll do public t, the t, find min, throws empty collection exception. Well, it's going to take us a while to debug this, to go through those, probably take a while. So we'll try to do it quickly. So we'll say public t find min, throws empty collection exception. Then here we'll say, what are we going to say? We'll say if is empty, throw new empty collection exception. We'll say array heap. Else we'll return tree of array index 0 dot get element. Do we have no? We don't have a node class, so that should be t result points to tree of index 0 array index 0 turn result. Does that work? I'm just gonna check my other notes to see what I did, just to make sure that's correct. I don't think that would be wrong. I just want to make sure, because last time in the linked I had to make another short video or clip of the video to throw this exception. If it's empty, I forgot about that. So I'm just going to double check so I don't have to do that again and confuse you guys even more. So we'll check resources. Let's see. Okay, so this is the array heap. This class itself is the array heap also. Just opening that up. Doing with my opposite hand here. So then we have heapify remove. We're done. Find min. Okay, so we have it just returns tree of index 0. Return tree of index 0. So that works as well. That's even easier. Well, that's what I did originally, I think. But you can save it to a variable if that works fine. You'll probably get even extra credits for just going above and beyond anyways. That should be good. We have everything. Alright, let me just take a sip of my water actually. Do I even have water here? I do. So you can take a little break, take a little breather, maybe stretch a little bit if you want. Play a song, whatever you want. You can check the euro, check the dollar. No, I'm just joking. Actually, that's what I would do. That's what I was doing actually. Because at the time of the video, the euro's the dollar's at an all-time high right now. Not an all-time high, almost an all-time high. It's like a 14-week high or something. And everyone's like, yeah, buy the dollar. And I'm like the only one in the chat room saying short it, and they're all getting mad. They're all getting super mad at me. Alright, so now let's let us start probably creating some objects here. So we're going to check the array heap. We're going to add. It shouldn't take too long. I don't think. I guess we could heapify. We'll do one. We're gonna add an element first. So we'll say excuse me. Let's create an array heap of type integer. We'll call it heap pointed to new array heap have type integer, and then we'll say heap dot add element. We'll add 5. Okay, yeah. So let's just run it to make sure it works. We probably have some save and run. We probably have some errors somewhere, unfortunately, with all those brackets. I should probably get that code up just in case as well. Level order. Oh, that's from binary tree ADT. So let's take that out because like I said, we skipped the iterators. There's some iterators for this. Honestly, we've already done those, so I'm sure you can do that yourself. This is just the data. This is the data structure itself video, so we'll take that out for now. And we don't even need that. So let's go for that. Save and run that. Iterator level order in binary tree ADT. Didn't I just take that out? Extends array binary tree. Does not override abstract method. Iterator level order in binary tree ADT. I just took that out. Am I forgetting some brackets here? No. I think it's glitching out. Extends public class array heap, extends array heap, array binary tree, implements heap ADT, heap ADT. You just have 3 methods in there. Oh, here we go. This is why. Hopefully we don't. Is that why? Hopefully it is. Oh, thank God. Alright, so it worked. You can add that stuff back later if you want to do the iterators. You can figure it out. It's not that hard. We're just using the same iterators as last time. You create a private inner class, set up the iterators like we did before in the other tree. That code ended up being, was it over 4 hours? I want to say it was almost 6 hours. That was crazy. So I'm not trying to do that again. This one's already probably over 2, maybe almost about 2 now. So I think after we do the debugging, it's going to be 3. So we will set a breakpoint here. Hopefully not. We'll set a breakpoint here. I mean, hopefully it doesn't take that long. So we have, oh, that's way too many elements. Where is it? Let's just change this to like 5 so we don't have to waste so much memory. Save and run that. Then debug it again. Alright, so we have our array heap stored at memory location 952. We'll actually, no, you know what, we'll set the object up to. So I put a breakpoint there and then I'm going to restart it. We'll go through the constructors to set it up so there's no parameters. So it went into the array heap. So super will step in. It's going to set up the instance data of array binary tree. Count points to 0. Didn't we have some other methods? Array binary, doesn't array binary tree extend link binary tree? Oh, guess not, that's okay. You could have done that as well, probably. But that's fine, we don't need to do that. The class is super long anyways. Where are we here? Up here. Okay, so count is set to 0. Our array is instantiated. Then we'll add the element. Here we go, we have our array heap. Has count as 0. Has a tree array and a mod count. So we'll step into heap.addElement. So we'll go if count is equal to tree.length. So we have a tree.length that here is equal to 5 because we have 5 elements. So we have our array instantiated to size 5, which is index 0 to 4. So we won't have to expand capacity, so we'll say, okay, well, tree of index 0 points to the object. Tree of index 0 points to 5. Count plus plus. Mod count plus plus. If count is greater than 1, heap if I add. There you go. That was done. Easy. That one was easy. But if we, let's say we want to add a 4, let's go backwards. Then we're going to go into the heap if I add method probably. So I'll add a 4 here. We'll take those breakpoints out. We'll put 1 there. We'll save that and run it. Actually, we'll stop running that and then we'll rerun it. Excuse me. My nose is running again. Not running, sorry. My nose is always stuffed because it's like getting cold here. It's like 33 degrees or something Fahrenheit. I don't know Fahrenheit, but it's like 1 degree. I'm assuming that everyone is like mostly American watching this video. Just cause well, there's, I don't know how many Canadians will watch this video, maybe some international people, that's cool. I'm just assuming the majority will be from the United States, but it's just a small channel anyways, maybe like next year or something. I don't know when you watch this, but whenever you do, it's like, it's getting on to December now. So anyways, we will just step into this method. We'll add 4. If count is equal to tree.length, that's false because count is 1, tree.length is 5. So that's false. Does 1 equal to 5? It doesn't, right? So we'll skip it. Then we'll say, well, tree of array index count. Tree of array index count, which is 1. That's the empty one. That's the next one. It's going to point to obj. And remember the formula. Did I tell you the formula already? I think I did. Right here, yeah. This stuff, remember, don't forget that. So I don't know what, I made this is like the 4th part of this video. So this is a formula for it. You can pause the video, I've already explained this. I'll have already explained this in the beginning of the video. I've already explained this in the beginning. So we have the root at array index 0 always, and the left child is at index 2n plus 1 of n. So n is going to be the index you're looking for. Its child. So if we want the root's child, then we're going to put a 0 for n. We're going to get the left child's index, and if we want the right child, we'll put a 0 for n here. And we'll get the right index, which will be 0, 1, and then 2. So it'll be 2. So all that, and then you can work backwards and divide it. So you can get the parent of the node. So we will continue with that wherever we were here. Count plus plus. Mod count plus plus if count is greater than 1, which it is. Heap if I add. Excuse me. So we have, it's probably below my nose. I don't have any tissues around here. So we have heap if I add. We have a temp set to null. Int next points to count -1. So since count was incremented, we're going to decrement it. Then temp points to tree of array index next. Temp points to tree of array indexed next. So temp points to tree of array index next. What's tree of array index next, which is 1. So temp points to 4, I believe. Temp, there you go, 4. While next is not equal to 0, that's true. Not sure why it doesn't want it equal to 0, but that's okay. Because it's not going by the this is not going by the index, it's going by the value itself, so I'm just trying to figure out why, but hopefully we'll find out. Or otherwise it doesn't really matter. So we'll have a comparable casted to temp. So we'll say temp. Where's temp? Temp, or here somewhere. Here it is. 4. So while 4.compare to tree of, here's some division, so next, which is 1 minus 1, so 0 divided by 2 is 0. So I'm going to have to put these brackets here. I'm going to have to put some substitution here, so temp is 4.compare to next minus 1, 1 minus 1, 0 divided by 2. I feel like I have a mistake here. I'm just going to check my notes here just to check. This is heap if I add. Let me just check, because wondering why the zero's there. Forgotten. This is heap if I add, while next is not equal to 0. Oh, I know why. Because we want the index. So I think we're gonna use this as the index, and we're checking if it's the root. I think that's it. I can't think of any other reason. So hopefully that's it. That is correct. So we'll just so hopefully that clears up any confusion. So we'll say next, which is 1, is not equal to 0. So because why are we having these 1 in numbers, right? These are indexes we're gonna use in a sec. So we have our tree. It's 5 and 4. Right now the 5 is the root, and the 4 is the left child. So we're gonna be switching those. So while next. Where's next, by the way? So while next is not equal to 0, that's true. And temp, which is 4.compare to, that all is 0. 4.compare to 0 is less than 0. Well, is that true? 4.compare to 0 is less than 0. No, that's false. If it was 0.compare to 4, that would be true, so that should be false. We should be able to skip that. No, that's actually true. What did I mess up here? So while next does not equal to 0, that's true, and comparable of temp, which is 4. Oh, sorry, there's an array index there. My bad. There's no array index here. Right, there's an array index there. Okay, so apologize for that. Hopefully I'm not confusing anyone. So we'll just redo that line. So while comparable casted to temp, so temp's 4. 4.compare to tree of array index. So this is array index, not 0 itself. So we want the value in the array index at array index 0. So 5. So we have the array elements 5 and 4. Now that's correct. That's looking a little bit more correct. So we're saying, okay, well, is 4 dot compared to array index 0? Whoops, less than 0. So maybe I'll just take that out. Dot compared to 0 is less than 0. Nope. Compared to 5. Because compared to tree of array index next. 1, so next minus 1, array index, next minus 1, so 1 minus 1 is 0 divided by 2. 0 divided by 2 is 0, so array index 0. So 4 dot compared to array index 0, which is 5, is less than 0. Well, is 4 dot compared to 5 less than 0? It is, so that's true, so I apologize for that. It's getting a little late here, it's like almost 11. But hopefully that clears up any confusion, and I'll try to see those brackets a little bit better. So we'll tree of array index next, which is tree of array index next, which is 1. So array index next, so while tree of array index next, well, what's tree of array index next? Access our tree, we're going to put a 1 in for our tree index. So tree and then index 1, which is 4. So tree of index 4, whoops, no, tree of index 1, sorry, points to, it was 4 previously. So now we're going to say tree of index 1, tree of array index 1 is going to point to tree of array index. We might have to do some calculations on the side here. We'll just say index, we'll say tree of index next minus 1. So 1 minus 1 divided by 2. So 1, next is 1, so we put a 1 for next, or substitute a 1 for next, so 1 minus 1 divided by 2, that's 0 divided by 2, which is 0. So we'll say tree of array index next, which is tree of array index 1, points to tree of array index 0. So a 5 is going to go in that position. You'll see a 5 pop up right there where that blue line is highlighted. It didn't swap yet. Tree of array index next. Tree of array index 1 points to tree of array index next, which is 1 minus 1, which is 0 divided by 2. Say it's pointing to 4. Tree of array index next, which is 1. Am I getting something wrong here? Next. 1 minus 1, that's 0. Unless I'm getting the Java division wrong. 1 minus 1 divided by 2. 1 minus 1 is 0 divided by 2. They're saying that's 1. Might have to just double check here on a separate compiler, so I apologize for that, just to double check it. So we have 0, so 1, next is 1. So 1 minus 1, that's 0 divided by 2. Okay, so we're going to check 0 divided by 2. Just going to print that out. You can't see this out, this is just on a separate computer, so it does say that it's 0. So unless there's like a glitch or something, we're just going to redouble check that line. So tree of, because it didn't update here. it's saying tree of next minus 1. 1 minus 1. Yeah, 1 minus 1, that's 0. Divided by 2. Tree of index 0 should have been, I'm getting 5. So I'm trying to figure out why that's off by 1. Tree of array index next, which is 1. Tree of array index 1. Or do we swap them? Tree of array index 1, which is 4, points to tree of array index next is here, unless it's glitching out. 1 minus 1. Which is 0 divided by 2. Tree of index 0 next points to. I'm wondering if I might have hit a space somewhere and it's on the wrong line. That might be true. So let's just stop that for a sec, because that can happen. We'll re-debug and try to get back to that line. For some reason there's not getting the same answer that they're getting. So we'll just step in here. Where were we? We were in the first iteration here. So okay, so we have. Let me just remove this. Remove this. Okay, so tree of array index next. There's our tree array index next is 4. Tree of array index 1, right here. Points to tree of array index next. The number, which is 1, minus 1, which is 0, divided by 2. So tree of array index 1 points to tree of array index. It seems like this number should be copied here. So tree of array index. Can we maybe just print that? So we'll just take this. No, actually that's not going to work, is it? Tree of 1 minus 1, that's 0 divided by 2. Yeah, it should be 0 divided by 2 is 0, I just checked it here. The tree of 1 should point to yeah, it says down here tree of next, which is 1, minus 1, which is 0. It has the same thing here written, the same calculation written with different memory locations. It has next minus 1 divided by 2, and the same calculation written with the same number. So all what should be happening here is this index should be copied to that one. Like it should be saying tree of array index 1 points to tree of array index 0, so the 5 should go down here. That's what should be happening. That's not what happened, is it? And then next points to next minus 1. So next points to next minus 1 divided by 0, so the next should become 0. It does become 0. So maybe the tree itself isn't swapping yet. Where is our tree here? It did say it was 0 though, so that's correct. because we said 1 minus 1 divided by 2. That's the same thing as here. So while next is not equal to 0, that's false. Maybe it's just going to set it at the end. Sometimes the compiler can glitch out as well. So while tree of array index next, because what it should point to temps, tree of array index next. Tree of array index next, which is 0, should point to temp, which is 4. So sometimes what can happen is that the compiler can glitch out, or it may not update the way you want it to till later. But what should have happened here is that 5 should have switched with 4. It should have set tree of array index next, which at the time was 1, which is this one, points to tree of index 0, so the 5 should get copied there, and tree of index 0 should have gotten set to temp. Let's see what happens here. Let's see our heap. You know what, I think we have an error somewhere. Because look, our element's gone. That's probably why. There's an error somewhere, I think. So let me just pull the code up, because I was like, wait, that doesn't make sense. It has to be copied over. Probably like this. My viewers are probably like, well, what's happening here, right? So I'm trying not to confuse you guys. I think there's an error here, so I'm just gonna double check. Ttemp points to, or ttemp is null. And we're saying int next points to count minus 1, temp points to tree of array index next, while next is not equal to 0, and comparable of temp dot compare to tree of next minus 1 divided by 2 is less than 0. We have tree of next. Tree of array index next points to tree of array index next minus 1. Okay, so there is a mistake here. There's supposed to be a bracket there. What was happening? What was wrong with before? That before, sorry. 1 minus 1, which is 0, divided by 2. Okay, and now what's happening now? 1 minus 1. 1 next minus 1, which is 0. Minus 1, sorry, yeah, 1 minus 1. Then take the index of that. I'm not seeing any difference here, but for Java might have messed things up for it. So that's why I was like, what the heck is happening here? You guys are probably like, dude, this guy doesn't even know what he's talking about. I swear to God, I did the calculation like 1,000,000 times. I was getting 0. So hopefully you're still watching, and we'll just figure it out here. So there is an error here. Tree of array index next points to tree of array index next minus 1. Then there's a missing parentheses divided by 2 without a bracket, or without a parentheses there. So maybe that itself messed the compiler up. So hopefully it didn't. We'll just check this one up here too. So tree of array index next minus 1 parentheses divided by 2 array index, or array square bracket parentheses less than 0. Yeah, with so many brackets and stuff, it can get confusing. You may find mistakes like that. So tree of array index next points to temp. Okay, I feel like something here might have the same problem. Hopefully not. But yeah, that took like an extra 20 minutes, so I apologize for that. Hopefully you're still watching. Excuse me. So we'll go through that again. We'll save that. We are still debugging, so we'll run that. It's getting late here, so we'll probably just do these, and we'll take a break, and we'll come back and do the rest later. For you, I don't think you're going to notice that, But anyways, we'll just start with stepping into that. So where were we? We're in Heapify add, step in. We were here. So tree of array index next, which is 1. So tree of array index, where is our tree? Can we open that? Hopefully it works this time. So tree of array index next, which is 1. So tree of array index 1, which is this one, points to tree of array index 1 minus 1 divided by 2. So we should get a 5 pop up there. There we go, finally. I was like, what the heck is going on? This thing isn't even changing. I was like, there's no way that has to be correct. And then anyway, so now it's we're saying next gets changed to next minus 1. Where's next? Next is here, so 1. So next, the 1's going to get erased in a sec, so we're going to say take this next. We're going to take the 1 out, so next now points to next, which is currently 1 minus 1, which is 0 divided by 2. So it should say 0 there. I might get mixed up on the Java division somewhere, but it's saying now we've looped back up here. We're gonna up here, so down to this bracket, up, back up here. So then we're gonna say while next is not equal to null. Sorry, next is not equal to 0. Well, it is equal to 0, so that's false. We're gonna skip this whole thing. Tree of array index next, which is 0, points to temp, which is 4. So we've now swapped the elements to heapify it. There we go. 4 is now our root, and 5 is our left child. So that should be it. So what else is really happening in there? If in the heapify remove, heapify add, if it finds that there's more elements that are in the wrong order, it's just going to continue doing this. So we've gone through all those statements there. We've gone through all these statements here. So we're going to take a break, and when we come back, we'll finish the remove min and the heapify remove. Actually, maybe you could do it right now. We're getting past an hour. I kind of just want to do it now. Well, I'm just gonna have a sip of water. Excuse me. Let's take a sec here. I don't know how many hours we're in now, so this can happen, by the way, if it's a long video. Alright, so we could remove maybe 1 or 2 and be done with it. So don't have to come back later. So remove min. We're going to remove the min, and then we're going to heapify remove. If there's one element, it shouldn't be too bad. So how many elements are you going to need for this? Probably at least 3. So how is it going to look like? Well, if we remove, let's say we have 5, 6, 11. I don't know how many hours, I lost track. I think we're over to 3 now. So that's why I kind of like take drinks here and there, whatnot. So we'll do heap.add element here. We'll add 11. What is our heap going to look like now? Well, it's going to look like something like this. We have 5, 6, 11. So what's going to happen? We're going to take the min element out. Right? Then we're going to put the 11 up there, because it gets, let me just go back for a sec. So when that happens, when we take the minimum element out, it gets replaced with the last node. Then what's going to happen? Probably a heapify. So 11 is going to be shifted here, and that's going to be our heap. And then if we want to add another element at the end, we can add an element. So that's that is what we are going to go for. So let's just reverse that. Put a 5 here, 6 here, and 11. Let's stop that. See what method we're going to use. So this one, remove min. And we're going to try to go through those. Okay, so here we will say heap.remove min. And we're going to step into that. We're going to create a breakpoint and then start debugging it. I think we'll just finish shit up now, because if not, I'm going to be coming back later on trying to do it. So here we'll do heap.remove min. We have our heap here, tree. Here's our elements, 5, 6, 11 right there. We'll step in. If is empty, throw a new empty collection exception. It's not empty. We're saying, okay, well, the minimum element points to tree of index 0, the root's in the minimum element. Tree of index 0 points to tree of count -1. What's count of -1? That's 2. So now tree of index 0 is going to get switched with the last node, as we said. Done. 11, 6, 11 now. The index 2 is still there. Guess we didn't set it to null yet. Now to see if it's correct. There's something wrong with this code. I think there is. Tree. Yeah, we still have the element in there, so let me just check the code again. God, I thought it was already. There wasn't any mistakes, so I guess there is. So we are in the heap of, no, we're in the remove min. Might be missing a line somewhere, so array heap. So if is empty, throw a new empty collection exception, array heap. That's fine. T minimum element points to tree of index 0. Tree of index 0 points to tree of count -1. Heapify remove count minus mod count minus return min element. Unless there's a glitch in the code itself. If not, we can add a statement to try to fix it. So we have heapify remove. Node is 0, 1 is left is 1, right is 2, int next. If tree of array index left points to null, and tree of array index right points to null, next points to count, else if tree of array index right is equal to null, next points to left. Else if comparable of tree of index left compared to tree of index right is less than 0, next points to left. Else next points to right. 10 points to tree of array index node. While next is less than count and comparable of tree of array index next compared to temp. Whoops, let me just go back here for a sec. So while comparable casted to tree of array index next compared to temp is less than 0. Tree of array index node points to tree of array index next, node points to next. Left points to 2 times node plus 1, right points to 2 times. Here we go. So there's a missing parentheses here. So that, because that would be 2 times node plus 2. That's what happened. So hopefully that fixes it. So we'll say if tree of array index left is equal to null and tree of array index right is equal to null, next points to count. Else if tree of array index right is equal to null, next points to left. Else if comparable cast it to tree of array index left dot compare to tree of array index right is less than 0, next points to left, else next points to right, tree of array index node points to temp. So hopefully that solves it. We'll save that, go back to main, stop that and run it. Okay, so we'll step in. We'll check the heap to see if it was updated. Oh, still like that. Heap. The count is updated. You know, I think there was an error in this code, now that I remember. Okay, so what are we gonna do here? There was an error in this textbook, I'm remembering it now. So what can we do? Array of index 0 is swapped. What did I do for this? I know I did fix it now. That's what I was thinking. I was like, was there an error here? And now I'm thinking, I was like, yeah, I think there was an error here. Because I'm like the one in my class who like points out all the errors, like, yeah, there's an error here. That's wrong. And I remember making a post about it. Now that I remember. So what we want to do is delete that last index. Because we had, what do we have? 5, 6, 11. Then removing the minimum, which is 5. Putting 11 to the top. We're shifting 11 to the top. After we remove 5, we're going to shift 11 to the top and then swap 6 and 11. So I believe that 11 in array index 2 should be deleted. Now how did I delete that? Heap if I remove maybe here. Tree of array index. What is count? 0, 1, 2. We'll say tree of array index count points to null. Will that fix it? Tree of array index count. Tree of array index count. Count is 2. 0, 1, 2 would point to null. I mean, it should. Hopefully it does. We want it to work in all situations, right? Not just this one, but hopefully it does work, at least in this one. Skip. Okay. Mod count. Nope. 0. Why did that happen? Tree of array index count. Tree of array index count 0, 1, 2 points to null. So what's wrong with that? Let's try to redo that again. Okay. Tree of array index. Oh, so count is 3. So we have to stop that. Move that down here. Decrement count first, then execute that line. Maybe we need to do something with mod count as well. Probably put mod count there too. So we'll swap those. Then we'll set the element to null to delete it from the tree. And hopefully it works this time, and hopefully that it works in all situations as well. Okay. tree, and there we go. So that last one was set to null, so hopefully that's correct. Does it work in all situations? Well, it should. It should, because it's something that happens at the very last step. If you remove the min, then the very last node should get deleted at the very end. So it seems like it should work. You can always do length -1 as well, I think. Where were we though? We go through heapify remove already? I don't think we did. Did we? I don't think we did, because that was a long one. I don't remember going through that. Did I skip it maybe? Just to check something. Anyways, we'll just we'll set the t minimum element to tree of index 0. So the minimum element is, do not want the flag, there's a tree of index 0. So t min element points to tree of array index 0. That's 5. So t min element, right, points to tree of array. So minimum element points to the array of index, tree of index 0. Sorry, it's getting a little late here. So then we'll do tree of array index 0 points to tree of array index count, which is 3 minus 1. So that's going to get the last node. Did we do this already? Yeah, we swapped the nodes, right? So we're taking 5 out and we're putting 11 there. I don't remember going through heapify remove with you guys, so that's okay. We'll just go. I think we might have skipped that line, so we'll go in here. We'll say node is equal to 0, 1, left is equal to 1, right is equal to 2. If tree of array index left, which is 1, is equal to null, well, is tree of index left equal to null? This tree index 1, if tree of array index left, which is 1, is tree of array index 1 equal to null? Well, it's not, and tree of array index right, which is 2, which is 2 is equal to null? Well, it's not. So that should be false. Else if tree of array index right is equal to null, well, this tree of array index right, which is 2, tree of array index right, which is 2, tree of array index right is 2, is equal to null. That should be false. Else if comparable of so else if tree of array index left, which is 1, so I'm gonna have to put here 1 dot compare to tree of right, which is 2, so 1 dot compare to 2. No, I feel like I'm getting something wrong here. The index, sorry, so tree of array index left, which is 1. We're going to say, okay, index 1. Tree of array index left is 1. The tree of array index 1 dot compare to tree of array index 2 instead of the 2. The index 2, not the actual number 2 itself. So index 1 dot compare to index 2, well, what is that? That's 6 dot compare to 11. So I'll just do a little arrow. What was that? The lambda. Except we didn't use a lambda in this. Except for JavaFX. So we'll just do 1 dot compare to, so 6 dot compare to 11. Is that less than 0? Is 6 less than 11? It is. So next, where is next? Next is a good question. Where is next? Unless it's just right there and I can't see it. Next points to left. I really don't see next. Node right, right. Node left. Did I hit a line somewhere? I mean, did I hit a space? No. Okay, well, maybe it's just glitching out. That can happen sometimes. Did I hit a flag? What happened there? I just clicked something. There we okay, so we're on this one. Well, we're on this version of it. I'm not sure what I did, but I've seen this version before. That's where you can't remove the watches. I still don't see next. We'll just execute this line. Oh, wait, you know why? I think because it's null at this point. That's why. It doesn't show any null elements. So we'll say next points to left, which is 1. There we go. Next points to 1. Then we'll say, okay, well, 10 points to tree of array index node. Excuse me. Where's temp? Is temp also node? It is. Sorry, null. So we'll say 10 points to tree of array index. 10 points to tree of array index node. Temp points to tree of array index node, which is 0. Where's our tree? Index 0. So temp should point to 11. Right there. Highlighted in the nice blue color. And we'll say while next is less than count. So while next, where's next now? So next is 1. So while 1 is less than count, which is, what is count? 3. And comparable, so while 1 is less than 3 and tree of array index 1. So I need to do those nodes here, or else it's going to, I'm going to lose track of what we're comparing. So while, actually, you know what? I'm just going to get a sip of water. Apologize. It's like an hour and a half now. So this video is going to be like I think at least 4 hours. I was hoping it wasn't going to be that long. YouTube's going to be like, well, that's a long video. Anyway, so we'll do, we'll have ones that are like 6 hours, more than that. So so we're here, we're doing this part. So while comparable of tree of array index next, which is 1, dot compare to, so we're going to say, okay, well, tree of array index next, which is 1, so tree of array index 1 dot compare to temp. What's temp? Temp is 11. Okay, so we're just doing one index and one number, it looks like. Has less than 0, so we'll take that out. We'll say tree of array index 1. That's 6. So 6 dot compare to 11 is less than 0. Is 6 dot compare to 11 less than 0? Well, it's true because it returns -1. So that should be true. We'll step in, so tree of array index node, which is 0. Tree of array index 0 points to tree of array index next, which is 1. So we're saying we're at that swap thing again. Excuse me, so we're saying tree of array index node, which is right here, 0, points to tree of array index 1, so 6 should go there. There we go. Then we're saying node points to next. Node, which is 0, points to next, which is 1. Left points to 2 times node, so 2 times 1. 2 times 1, which is 2 plus 1, that should be 3. Then right points to 2 times 1 plus 1, so it should be 4, I think. Then we'll say if tree of array index left, which is 3. So if tree of array index 3 is null and tree of array index right is null, that should be true because we only have up to 2 and it's asking for 3 and 4. The next points to count. What's count? Count is 3. So next points to 3. What happened there? Next points to 3. Okay. So how's our okay? Yeah, that should be good now. So while next is 3 is less than count, was 3 less than 3? So it's saying while next is less than count up here. Right there. I just highlighted that. In the while statement, while next. So while 3 is less than 3. Is 3 less than 3? 3 is not less than 3. 3 is equal to 3. So that's going to get skipped. Should be. So it's saying, okay, well, tree of array index node, which is tree of array index 1, points to temp, which should be stored as 11 from earlier on. So tree of array index 1 gets stored to, tree of array index 1, yeah, so it does get, it points to temp, which is 11. So tree of array index 1 right here points to 11. There we go, 11, and we're going to decrement, count, and mod count, and then set that last element to null. There's our tree to get rid of that element, and bam, we're done. Return min element. Finally. So we're finally done. The array heap, that should be everything. Did we test we didn't test that last one, just the one liner. So we'll say system.out.print println. We'll say the min is, or we can say the min, usually the min is the min element. The min element is, so a string concatenation plus tree dot remove min. No, that's wrong. Tree dot find min. So no, not tree. Heap dot find min. Our object is a heap. Find min is our method. Find min, it should return us tree of index 0. Well, what's our minimum after that? It should be 6. So we'll just print that out. There we go, the minimum is 6. So that concludes our array heap. I hope I didn't confuse you too much. Hopefully you do understand now. If you are having problems with it still, I would watch this video a few times. Go through it in your IDE. Use a compiler to do the calculations if you get stuck doing more levels, because we just did 2 levels. But if you're doing 3 or 4, it could be a lot, it could be more complicated, the division could be more complicated. You may need to use a Java calculator for that. But yeah, that concludes our array heap. So we're done with trees now. We just have, what do we have? We have a graph to do, and we have a hash function, and we're done. So I hope this helped you. If this video did help you, you can subscribe to my channel if you'd like. If you'd like to see more free educational content on coding videos or anything trading or investing, you can subscribe to my channel if you'd like. If not, that's alright, and I'll see you guys next time. Take care.